Go to 18. 18 says, f is a function whose second derivative is given here. So the formula for f double prime is right there. What are the x-coordinates of the point of inflection on f? So that's Danica's chart. Without writing all of the chart, I remember that when f changes concavity, f double prime changes positive to negative or vice versa. So that's just a portion of Danica's chart. So I'm looking for when f does this, but as is typical, I don't have f to look at. I have to look at f double prime, so I'm looking for when f double prime does this. Question? Okay, there's more than one way to solve this problem. I'm going to show you a method that how do I say it? It coincides with things you learned last year, so I'm hoping this will make this go pretty fast. You spent some amount of time last year learning how to graph something like this. You learned that if f double prime, that function, you didn't call it f double prime, you just called it some function. That function is in factored form. So in factored form, it becomes easy to see the values of x, which cause this function to have a y value of 0. So in factored form, the values of x, which will cause this function to equal 0, are easy to see. Raise your hand if you can tell me at what x values will this function equal 0. Like we're drawing out f double prime here. We don't really care to have a really good graph. We just want enough to answer the question. At what x values will f double prime equal 0? There we go. Let's go, Sam.
It's at 0, 3, and 6.
When I have three factors multiplying, I don't have to look at all three simultaneously. I can pay attention to only one of them. If x were to equal 0, that would mean I have a 0 here, here, and here. But these two here don't make any difference at all, because once this is 0, 0 times whatever will be 0. So I definitely have, when x equals 0, the y-coordinate of f double prime is 0. Right there. Hands up if you knew that one. 2.3%. The other two, x equal 3, x equals 6. Okay, watch out for an AP trick. We're looking for f double prime changes from positive to negative or vice versa. You learned last year that when this is x squared, I guess a lot of teachers call it a bounce. That's what Mr. Rector was calling it yesterday. So this graph of f double prime is going to do something like this. It's going to start somewhere up here. It's going to come down, touch, and then it's going to go back up some amount and end up doing that. Not necessarily exactly like that, but enough like that to answer the question. That was what you learned last year. So now you know that right here, f double prime is changing from positive to negative. Right here, f double prime is changing from negative to positive. Question? Please.
And so it's not e because when it hits 0, it just touches, it doesn't go into negative.
Right. If you're looking at, like Danica's chart is saying, look at all the y-coordinates of f double prime. So this y-coordinate, Carl, is positive or negative?
Positive.
This one?
Positive.
I know it's kind of down. This one?
Positive. Positive.
This one?
0.
This one?
Positive.
Right. So I never had this happen. I never had the y-coordinates change from positive to negative. Does that answer your question?
Yeah.
2 point, please.
Wait, why did you say it's not 0? Wait, if did you just mean that?
Let's keep talking for a minute. Are you comfortable that when they say, what are the x coordinates of the points of inflection for f, that means I'm trying to see when f changes from either being concave up to concave down, or f changes from being concave down to concave up. Does that make sense?
Yeah.
Good. But I don't have f to look at. Danica's chart says I don't need to. I can instead look for a different type of change on f double prime that will coincide with f doing this. So I'm looking to see if I can see any y coordinates of f double prime ever changing from being positive y coordinates to being negative y coordinates, or vice versa. Have I answered your question?
Yeah.
Perfect. 3 points, please.
Okay, so with the x squared or whatever, we know that it bounces on 0 or whatever. So is that the only way that something can bounce, or could it be like x to the power of 4? Would that also bounce? Or?
Yeah, even powers for sure.
Okay.
And then we'll hit some other things. Like I'll show you, I won't do it today, but the functions will get a little more complex. We'll kind of talk about it some more. Yeah, x squared, x to the 4th, x to the 6th would all have that bounce effect. So. Cool. Stop that one.